So picture a triangle made entirely of numbers, 100 rows deep. You start at the very top, and on every row down, you can only step to one of two numbers directly below you. The question is pretty simple. Which path down gives you the biggest possible total? Here's the catch. There are 2 to the power of 99 possible paths through this triangle. If you had a computer that could check 1 trillion paths every single second, checking every single one would take over 20 billion years, longer than the universe has ever existed. So this time I handed the problem to 4 current models: Kimi K3, Claude's Fable, GPT 5.6 Sol, and Grok 4.5 with no hints. And the results split in a way that actually surprised me, because the model that finished fastest wasn't the one that got it right. So here's exactly how the triangle works. At the very top, there's a single number, the next row has 2 numbers below it, and as you move down to whichever one is adjacent to where you're standing, every row that gives you the same choice: step left or step right. And you keep going until you hit the bottom row, 100 rows down. Every step you take gets added to your running total, and the goal is to find a single path from top to bottom that adds up to the biggest possible number. Now, for a tiny triangle, let's say 4 or 5 rows, you could just try every path by hand and see which one wins. But this triangle has 100 rows, and every row roughly doubles your possible paths. So by the time you could reach the bottom, there are 2 to the 99th power different routes that you could have taken. The number is so large that brute force isn't slow, it's completely impossible. No computer that will ever be built could ever check the path before the sun burns out. So whatever method you use has to be smart about it, and turns out there's a genuinely elegant trick that makes this solution instant. So starting off with Grok 4.5 took the most straightforward possible approach, and it's the one that never actually finishes. Grok's program starts at the top, and every single step branches in 2 directions: one path where you go left and one path where you go right. It does this recursively, exploring every possible route all the way down to the bottom of the triangle. In theory, this is completely correct if it ever finished. It would absolutely be right. But it's checking every single possibility with no shortcuts, so it actually never finishes. That's the problem. With 100 rows, this program has to explore 2 to the 99th power branches, and as I keep repeating, that's simply impossible. So Grok's approach is basically disqualified, not because the logic is wrong, but because it never actually accounts for how explosively fast the search grows. So in that case, it's impossible to track how Grok's accuracy actually fares. So GPTs is the other one that actually worries me a little, because GPT 5.6 Sol finished faster than every other model, but it's the only one that actually got the wrong answer. GPT's approach was what's called greedy. Start at the top, at every row it just looks at the 2 numbers directly below it and picks whichever one is bigger. Right then and there. And then moves on. No looking further ahead, no reconsidering, just grab the bigger number in front of you and keep walking. It sounds reasonable. If you always take the better option available at each step, surely that adds up to the best possible total, right? But that's not actually how this triangle works. Sometimes the slightly smaller number in front of you will actually lead to much bigger numbers later down the road, and it shows in the actual solution that they wrote. GPT's greedy approach landed on 6580. The real answer is 7273. That's a gap of almost 700, just from taking the better option instead of thinking about where each choice actually leads. It's the fastest program of the 4, but it's also flat out wrong. So, Fable took a completely different approach, and it's actually built on pretty solid reasoning. Instead of guessing each step, Fable works backwards using recursion. It asks a simple question: what's the best possible total from this position all the way down to the bottom? And the answer for that, at the top of the triangle, it needs to answer the same question for the 2 positions below it, and so on, all the way down. Now, on its own, that sounds like it would explode into the same 2 to the 99th power that Grok ran into, but Fable adds one small crucial thing. It remembers every answer it's already worked out. So if 2 different paths ever ask about the same position in the triangle, it just looks up the answer instead of recalculating from scratch. That small single change is what makes this actually solvable. There are about 5,000 unique positions in a 100-row triangle, way more manageable than 2 to the 99th power paths. Fable never actually solves the same position twice. It just works through all of them and then builds back up to the correct answer. So it lands on exactly 7,273, the correct maximum path sum. So Kimi K3, the newest Chinese model, found the same correct answer as Fable, but got there with something noticeably leaner. Instead of starting at the top and reasoning downwards, Kimi starts at the very bottom row of the triangle and works upward. So for every adjacent numbers on a row, it looks at the row above and then adds the bigger of the 2 numbers to that number above. Once it's done for an entire row, that row now holds the best possible score from that position all the way to the bottom. And then it just repeats that one step over and over, moving up one row at a time until it reaches the very top. Whichever number is left at the top is the answer, because that by that point it already accounts for the best path through everything below it. So there's no recursion here, no functions calls stacking up on top of each other, no dictionary of cache results, just one array of numbers, updated in place row by row, climbing upwards. And it touches every position just once. And it shows in the numbers. Kimi K3 also landed in exactly 7,273, correct, but noticeably faster than Fable's version, because it skips the overhead of recursion entirely and just works straight through the data. So let's put all four side by side. Grok 4.5 tried to check every single path directly and never actually finished. GPT 5.6 Sol finished instantly by grabbing the bigger number in front of it, but that greedy shortcut landed on 6,580, which is wrong. Fable worked backward and memoized the recursion and landed on the correct 7,273. And Kimi K3 also worked from the bottom up, but instead of recursion, used a single array, also landing on 7,273. So one model never finished, one model finished first and was wrong, and two models were both correct, just with different speeds. So the winner this time is Kimi K3, and what stands out is just how little machinery it needed. While Fable proved the same result through recursion and cache, Kimi K3 got to the identical correct answer using nothing but a single row of numbers and a simple array. No recursion, no growing memory footprint, just a direct path to the truth. For a model that costs a fraction of what others do, that's genuinely a strong result. Fable takes a close second, the reasoning is completely sound and it proves the answer is correct at every single step along the way. It just does more work than is strictly needed. GPT 5.6 Sol is the one worth sitting with for a second because it was the fastest program by far, but it was greedy and the reasoning was not actually correct. Grok 4.5 wanted the certainty above everything else, trying to check every conceivable path, and it seems like that is possible when you just look at the number of rows, which is 100, but the number of paths is completely different at 2 to the 99, which made it impossible to complete. So the answer to this triangle is 7,273, the true maximum path sum from top to bottom, and sometimes the fastest model isn't actually the right one.